welcome to my class, and today we are going to start our topic on geometry. When we say geometry, usually it talks about lines, shapes, angles, and different figures. But specifically for today, as we start our topic on geometry, we're going to start with undefined terms, subset of a line, and angles. Let us start first with a short history of geometry. Euclid is famous as the father of geometry. The father of geometry because of his book, the title is Element, started the concept of geometry. And he introduced in this book the concept of undefined terms. Undefined because we are just going to describe these three terms. And let's start with the first one. The first undefined term in geometry is what you can see right now. So notice that you will see points. So this is what we call points. So a point in geometry is usually represented by a dot. And since it's a dot, it has no dimension, meaning it's just a location and it has no length. It's just a dot. And usually we name it using capital letters. So for example, here, this point, we can name it as point A. We can have point B, point C, point D, point E, point F, and G. We usually use capital letters in naming the point. After the point, of course, if you have many points or at least two set of points, and if you join them, you are going to form a line. And that is, according to Euclid, our second undefined terms. So we can describe a line by a straight path of points. So there are infinitely many points here. And if you have at least 2 points, you can form a line. And it has already one dimension, meaning it already has a length. And we name it according to the point that it has. So for example, this is line AB. And finally, if you have more than 2 points and we can connect those points, we have AD, BD, and AB. So that's when we form a plane already. So a plane is determined by at least 3 points. So if you have 3 points already, you connect them, you can already form a plane. It already has two dimensions. If a line only has length, a plane already can be described by 2 dimensions, meaning it has already a length, and at the same time, it can also have a width or a height. So that's what we have on a plane. So for example, here I will connect line HG, GE, HF, and EF. I was able to form a plane with 4 endpoints here. All right, so we finished the 3 undefined terms, which started with the point. For example, this is point A. If we have already 2 points, you connect them, you can form a line. And finally, if you have at least 3 points, you can already connect them and form a plane figure. So those are the undefined terms. Now, from the undefined terms started the whole concept of geometry. And as we go along with our discussion on this video, you will see related concept on points, lines, and planes. So let's start with concepts that are related to points. Now, as you can see here, I have point A, B, C, and D. Now, notice that when I connect A, B, and C, I will be able to form one straight line. And this one is what we call collinear points. These are points wherein it lie on the same line, meaning you can connect with a line using those 3 points. While the other points here, A, B, and D, So for example, here, I cannot form one straight line by connecting it. It is a non-collinear points, meaning these are points that do not lie on the same line. Now, we also have another set of points. Now, notice here, we are not talking about forming a line. In here, you will notice this set of points are on the same plane, while this one, the D, is not on that same plane. So coplanar points is what we call the points that lie on the same plane, meaning point A, B, and C here, we call them coplanar points because they are on the same plane. While we have, for example, A and D, they are not coplanar points, non-coplanar points, because A is on this plane while D is on another plane. We call them the non-coplanar points. So they do not lie on the same plane. So that's what we know about points: collinear and non-collinear, coplanar and non-coplanar. Now let's move on to lines. There are also relationship about lines that we need to know. And we are starting it with line pairs. So when we talk about line pairs, we have four types. Look at them. The first one is something that's similar to this. This one is the second type. The fourth kind is just a special kind of this one. And we have here a line that overlaps another line. So let us look at them one by one. So the first set of lines, if you look at them, they do not meet. So that's what we call the parallel lines. They are just lines that do not meet. They have equal distance in every part so that they will not meet already. Now, the next kind of line pair that we have here, unlike parallel lines that do not meet, this kind of line meet at a certain point. So they meet here, these lines meet here, while this one meets here. So this is what we call the intersecting lines. These are lines that meet at one point. So they meet at one point. Now we have a special kind of line here, intersecting line. There are also intersecting lines, but they form right angle. Later on, line angles, they form, we will know the measurement of the right angles. What the last type is, for example, this line, there's another line. They are overlapping with each other. So they have exact points, same position of points. And that's what we call the coincident lines. These are lines overlapping each other. So take note of the four lines: parallel line, intersecting lines, perpendicular line, and coincident lines. Now, aside from a line, there are also subset of a line, meaning the things that we can make out of a line. So for example here, we know that a line extends indefinitely, meaning it will be extending infinitely in both direction. But it has smaller parts, so we can take smaller part of that infinitely long line. And if we get, for example, this line which extend infinitely on both ends, meaning it is never ending, if I get only a part of that, for example, from E to F. So if I cut that, I will be able to form a line segment. So when we are actually drawing something, the lines that we are using are line segments, because this has beginning and an end. There's a start and finish. And it means since it has start and end, it has an exact measurement. Now, for example, here, I have another long line, meaning a never-ending line. A while ago, we got a line segment. But what if I'm only going to remove this part here? All right, so it means it's still never ending at one point only. So this one is the end and it will extend indefinitely on another side. So that's what we call array. Array is like a combination of a line and a line segment. And it only extends indefinitely in one direction. So again, that's the difference. If a line segment is on an exact measurement, array is part of a line, but it extends indefinitely in one direction. So again, do not be confused when you encountered line, array, and line segment. Let's discuss them further and compare them. Line segment, it has exact measurement, while line extends indefinitely in both direction. While comparing the three, I have here a line segment. It has exact measurement. I have here line EF. It has extended indefinitely in both direction. And I have here ray GH, which is only extending indefinitely in one direction. So line segment, I can write a notation by writing a straight line on top of it. It means that it's line CD, line segment CD. While if it's a line, I will use the symbol two-headed arrow if I want to represent a line, so line EF. And if I want to represent array, I will just have one direction arrow. So that's array, a line, and a line segment. Now that you know the concept of line, line segment, and ray, we can now move on to angles. Now, when we talk about angles, it has actually two rays. So look at here. You have two rays, right? So an angle is formed by two rays and with a common endpoint. So I can name this BAC, angle BAC, angle CAB. Take note, the order is important, meaning the middle, the endpoint, common endpoint is in the middle, while I can also name it as angle A by using the endpoint. Now, an angle has a measurement depending on its opening. So a while ago when I click this image, you will notice that I will be able to show you an opening of the angle. So the opening of that is the measurement of the angle. Now, we also have different kinds of angle. As I mentioned a while ago in perpendiculars, in perpendicular lines, we have right angle. So notice here, the symbol that we use for a right angle, there is a square part on the angle. Now, the measurement of this angle is exactly 90 degrees. And the small square indicates that this angle is actually measuring exactly 90 degrees. Now, aside from right angle, we have an acute angle. So the measurement is from greater than 0 degrees, but less than 90 degrees. So in this case, this one is an example of an acute angle. So look at this figure. So from that point up to that point, that's what we call an acute angle. So look at the image again. So it's from small up to right angle. So before it became a right angle, that's what we call an acute angle. Now, an obtuse angle now has measurement greater than 90 degrees. So this one should be greater than 90 degrees. This one is supposed to be here. All right, so it's greater than 90 degrees already. So how are we going to know that it's greater than 90 degrees? So if you just know that it's bigger than 90 degrees, but less than 180 degrees. So look at this image. So from this one going to that one is our obtuse angle. Now, we also have a straight angle. So a straight angle, the exact measurement is 180 degrees. So this one is measuring exactly 180 degrees. We also have a reflex angle. The reflex angle, it measures 180 but less than 360. So that's what we know about reflex angle. So look at this image. So from that one. So it's like a bigger angle already. And also the last one, we have a complete angle. So it means that it already revolved exactly 360 degrees. So the rays are overlapping each other already, and it make a complete 360 degrees rotation. So we have acute angle, right angle, obtuse angle, reflex angle, straight angle, and complete angle. And also, we have what we call the angle pairs. Angle pairs are two set of angles. So for example, here, I have an intersecting line, and I will be able to form several angles here. Adjacent angles are angles that are side by side each other. It has a common side. So for example here, angle ABC is adjacent to angle CBE. So they are side by side each other. They have common, this ray here, ray BC is their common side. So that's an example of adjacent angles. Another one, for example, angle CBE is also adjacent to EBT. All right, so it is side by side each other and it has a common side here. So that's what we call an adjacent angle. Now, having said that, there's also what we call vertical angles. If adjacent angle are side by side each other, vertical angles are not adjacent, meaning they are not side by side, but they are opposite each other. So for example here, I have angle CBE. What's the opposite? So the other one here, this one is its opposite, angle ABD. So it's the opposite. So that's what we call the vertical angle. Or for example here, angle ABC, the opposite is angle DBE. So they are the opposite angles, or what we call the vertical angles. We also take note of this. The two angles here has the same measurement. So that's what we call congruent angles. Congruent angles are angles with equal measurement. Take note, vertical angles are congruent. So if this is 50 degrees, the other side will be 50 degrees as well. So vertical angles are congruent. Another thing that you need to know, line pair. So a line pair are adjacent angles, side by side angle, angle ABC and angle CBE. So they are adjacent angles and they form one line. The opposite rays form one line. So here you can see that they form one line. Or here, CBE and EBD, they also form the opposite rays are forming one line. So that's what we call a linear pair. So in addition to linear pair angles, we also what we call the complementary angles and supplementary angles. We call the angle pair as complementary angles if the sum of the measurement of the angles is 90 degrees, meaning if you have angle A which is 50 degrees and angle B which is 40 degrees, if you add them together, the answer is 90 degrees. So they are what we call complementary angles. While if the sum of the measurement of the angle is 180 degrees, we call them supplementary angles. So for example, angle A is equal to 120 degrees while angle B is 60 degrees. If we add them together, 120 plus 60, we will have 180 degrees. So those are supplementary angles. So complementary angles and supplementary angles. Now, going back to line pairs, angles in linear pair are supplementary. So a while ago, I mentioned that angle ABC and CBE are linear pair. So if this is 50, now the measurement of this side, since they are supplementary, the total will be 180. So this one is 130 degrees. So that's what we mean by supplementary angle. So let us apply now what we've learned. So I have here an intersecting line and this angle here, angle GFI is 40 degrees. Knowing the relationship of the angles already, I can already identify the measurement of EFH, EFG, and HFI. So let's find EFH. EFH is here. All right. It is 40 degrees because it's opposite. It's the vertical angles and they are congruent. Now, EFG, since they are adjacent linear pair, so I will just have 140 degrees here to be able to sum up with 180 degrees. And since HFI is vertical to EFG, that is also 140 degrees. So I hope you've learned something new today.